All right, so what if you were asked about a question, what's the pH of a mixture of acids, right? A solution that has multiple different acids. And so this might seem like a pretty tough problem, but it actually ends up being very simple due to basically uh, the magnitude of things. So when you have multiple acids, you only care about the strongest, and basically you just ignore the rest. So you're only going to care about the strongest acid. So for example, if you have HCl, that's a strong acid. So if you have a lot of that in there, this is going to donate a lot of H+. And then let's say you added some formic acid. Draw the little Lewis structure for you here. Again, we're kind of noticing this motif here where we have an OH that's bonded to another thing with a double bonded O. And so this is a weak acid, so this will donate an H plus HCOO minus. And so the Ka here is equal to 1.8 times 10 to the negative 4. And so what we say about this kind of value and the H pluses that formic acid would add, we say that it's negligible. Basically, for every one HCl, you're going to get one H plus. For every one HCOOH, you're only going to get 1.8 times 10 to the negative 4 H pluses. And so it's just not nearly as important. So we'll just say negligible to the H plus from HCl. So really, you just have to know what one of them is. Here's the Lewis structure of this conjugate base in case you're interested in, right? It loses the H plus on the oxygen. And you can think about, we've actually been using this kind of concept this whole time. If we have two waters, they can self-ionize into H3O plus OH minus, where here now our Kw is equal to 1.0 times 10 to the negative 14. And so this, again, is negligible compared to the other ones. So when you have a mixture of acids, just focus on the concentration and the strength of one of the acids, right? So just going to rewrite this down. So for problems, only pay attention to the strongest acid. Ignore the rest. And then do a Rice table with the strongest acid. Next up, let's take a look at polyprotic acids. And so poly means many, protic is the proton or the H plus, and acids is donating it. So these donate more than one H plus, right? So you can have kind of diprotic acids. So for example, H2SO4 is a diprotic acid because it can donate one proton, and then it can donate another proton, right? So di means two, it can donate two protons. You can have triprotic acids. These will donate three protons, something like H3PO4, phosphoric acid. And so basically, you know, this kind of seems like it's going to be complicated as well because you have multiple sources of protons. However, it ends up actually not being that complicated at all. So, and that's because the Ka of the first proton, right, is much stronger than the subsequent protons. And so, right, so we'll call this kind of Ka1, and then these would be kind of, you know, Ka2, Ka3. And so Ka1 is going to be way stronger than Ka2 or Ka3. So you just ignore the rest of them and you just pay attention to Ka1. Right, because the Ka1, that's going to donate maybe 1 proton, and for every 1 proton it donates, the Ka2 is going to donate like 1,000th of a proton, a much, much less. And so you just have to really pay attention to the big values.